Hey guys, we're going to do lesson 4.2, angles of triangles. We are going to use the triangle angle sum theorem to find missing angles in this section. So the first theorem we have is the triangle angle sum theorem. And you've heard this one before, that the measures of what would be the interior angles of the triangle. So here's angle A, and then we have B and C. So if we add up the measures of those angles, they're going to add up to 180 degrees, and we can use that information to help us find some missing values in figures. So for the first problem here, it says find the measure of each number's angle. And we've got angle 1 here, angle 2, and angle 3. And so they're missing their measurements. When you solve a problem like this, you don't have to start with angle 1 and then go 2 and then go 3. You can start with any one that you want that you feel comfortable with. Or I would always start with definitely the easiest one first. So if I did that, I would actually start with angle 1 because it is part of triangle ABF there, and we have a right triangle. And I know from the triangle angle sum theorem that the measure of angle 1 plus the 90-degree angle plus the 48-degree angle is going to equal 180, and I would solve that equation. So I have the measure of angle 1 plus, that would be 138, is equal to 180. And then if I subtract 138, I'm going to get the measure of angle 1 is equal to 42 degrees. So if I wanted to, I could use that, or if it was possible, I could use that in finding the other ones as well. So angle 1 is 42 degrees, and I'll put that one down there. Then I'm going to go to angle 2, because I see that I have some of those little triangle markers that represent parallel lines. Okay, so here are parallel lines, and imagine this is our transversal here. And if our alternate interior angles theorem says that if we have parallel lines cut by a transversal, then alternate interior angles are congruent. So just by that, the measure of angle 2 would have to equal 39 degrees, and that's the alternate interior angles theorem. And for angle 3, I have a couple of things I could do. One of which is I could take the measure of 2 that I already have. We just found that out to be 39 degrees. And it is part of the right triangle here that has angle 3 in it. So according to that, the measure of angle 3 plus our right angle, which is 90 over here, plus angle 2, which we said was 39 degrees, has to equal 180. That's that triangle angle sum theorem. The measure of angle 3 plus 90 and 39 would be 129 is equal to 180. And then if I subtract 129 to get the measure of angle 3 is equal to 51 degrees. So there are my measurements. I have angle 1 is 42, angle 2 is 39, and angle 3 is 51. Okay, then on number 1A actually, we want to do the same thing. We're going to find some missing angles. I'm actually going to start with angle 2 here because I can see that it is part of triangle KLM, which we know 2 of the other angles. So the measure of angle 2 plus 71 plus 57 would have to equal 180. Triangle angle sum theorem. Then 71 and 57 would be 128. And then I would subtract 128, so the measure of angle 2 is equal to 52 degrees. Okay, and then I have also angle 1 and angle 3. Well, angle 1 and angle 3, although they're part of triangle JKL, I only know one other angle, so I'm going to have to go a different route. And what I'm going to do is I see that I have a linear pair here. The 57-degree angle and angle 1 are a linear pair, and according to the supplements theorem, they have to add up to 180. They're supplementary. So the measure of angle 1 plus 57 is equal to 180 because that's a linear pair. And we'll subtract 57, so the measure of angle 1 is 123 degrees. Now I can use that for angle 1. Now in triangle JKL, so I'll highlight that here, JKL, I now have two angles. I've got the 28-degree one and the 123-degree one, so I can use the triangle angle sum theorem to find angle 3. So the measure of angle 3 plus 123 plus 28 equals 180. The measure of angle 3 then would plus 151 equals 180. And then we'll subtract 151, we get 29 degrees. Okay, on the next page we have this concept of called the exterior angle theorem, and this one's a little tricky. First of all, let's define what an exterior angle is. We have interior angles, which would be angle A and B and C here. So all of those are interior angles because they're inside the triangle. An exterior would be on the outside. So way back in chapter 1, we talked about what an angle is, and an angle has a measure less than 180 degrees. If I were to think of my exterior angles as everything that's not on the interior, that would be a huge angle, way bigger than 180 degrees. So I don't want to do that. It has to be less than 180. To get that, what we'll do is we're going to take one side of our triangle and we're going to extend it out past the vertex and then create an angle with the adjacent side. Okay? If I had gone the other way, I would get 180 degrees. I want to do angle 1 here, and that's an exterior angle. Now this gets a little tricky. I'm going to use the next picture down here at the bottom. We actually have 3 exterior angles, and to do this we want to take each side and we're going to extend it, but we're going to extend them the same direction. So I'm extending the side and then I create an angle with the adjacent side. Then I go to the next side and I extend that side.
Mr. Arnett, if you're in the building, please call 2550. Mr. Arnett, if you're in the building, please call 2550.
I'm going to make another angle, and that's also an exterior angle. And then I'm going to take the third side and extend that and make an exterior angle. Notice that all of the exterior angles are going the same direction. I turn those counterclockwise. Let's take another triangle. Okay. And I'm going to do the same thing, but I'm just going to go the opposite direction. And that's fine, you can do that. So I'm going to extend a side and create an angle. This time I'm going counterclockwise, but I'm going to do the same thing for all of them, counterclockwise and counterclockwise. So all of those are exterior angles. Now what the exterior angle theorem says is that the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interiors. So in the picture on our theorem, let's say I give these some values. Let's say I give angle B a measurement of 120 degrees. And I give angle A a measurement of 20 degrees. So C, just based on the triangle angle sum theorem, would have to be 40. Okay, now let's figure out what angle 1 has to be using angle C. Because angle C and angle 1, which is the exterior angle, that's a linear pair, and so they're supplementary, which would make angle 1 equal to 140.
Mr. Hoopengarner, you can send those students down. Mr. Arnett's here.
So the theorem tells me that the measure of an exterior angle, which in this case is 140, is equal to the two remote interiors. So remote means far away, which means not next to. Angle C is next to the exterior angle, so we wouldn't count that one. We want the remote ones, and it's the sum of the angles that are further away that add up to the exterior angle. So if I look at the picture that I have here, I've already got some of it marked, and I've got interior angle 1, 2, 3, and I've got an exterior of 4 and 5 and 6. So according to this, and I'm going to make us some room here. According to this, if I were wanting to know what angles would give me 5, the remote interiors would be 1 and 2. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 5, which is an exterior. Which ones would give me 4? Well, the remote interiors would be 1 and 3. So the measure of angle 1 plus the measure of angle 3 would be the measure of angle 4. And then for 6, the remote interiors, again the ones that are further away, would be angles 2 and 3. So the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 6. All right, so that's how we do exterior angles. In the example, it says find the measure of each angle. We want the measure of angle 2. Well, I know that the 112, that's an exterior angle, and that the exteriors equal the sum of the remote interiors. So if I add the measure of angle 2 plus the 32 degree angle, that should be equal to the exterior angle, which is 112 degrees. And now I have an equation to solve. So the measure of angle 2 is equal to 80 degrees. Okay, in the second one, we're looking for the measure of angle MPQ. And so that's an exterior angle, and our remote interiors this time are angle M and angle N. P again is right next to it, so it's not remote, it's not in the distance. The measure of angle MPQ then would be 56 degrees plus 45 degrees, which is equal to 101. This next section, it says triangle angle sum corollaries. So when we had postulates, postulates were facts that we know. Theorems were ideas that were proven to be true. And corollaries are like extra things that we know because of a theorem or postulate. So some of these are kind of logical. Like the first one here says the acute angles of a right triangle are complementary. So it's saying that angle A and angle B have to be complementary or add up to 90 degrees. Well, that's because the triangle angle sum theorem says, well, they all add up to, all of the interior angles add up to 180. Well, I've already got a 90 degree angle here. So in order to add up to 180, angle A and angle B have to add up to 90 degrees together, so which would make them complementary because 90 and 90 is 180. Then in the second one, there can be at most one right or obtuse angle in a triangle. So it looks like maybe L is a right angle, could be obtuse. Well, if it's a right angle, 90 degrees is already taken up. So I can't have another 90 because the two remaining ones have to add up to 90. And if I have an obtuse angle, let's say if it's 110 degrees, well, J and K then would have to add up to 70 to get 180, which is acute angle. So I can't have any more obtuse ones. So I'm really more logical, but we can use those ideas. All right, in example 3, we're going to find some more missing angles. We have angle 1, 2, 3, and 4. So the easiest one to start with, I think, would be angle 1 because it's part of triangle TZY. The measure of angle 1 plus 90 plus 52 is equal to 180. That's a triangle angle sum theorem. And so we can add those together. And I get 142 equals 180. And then when we subtract 142, I get the measure of angle 1 is equal to 38 degrees. Okay, so this is 38 degrees. Then I'm going to, I think I'm going to do angle 2 because it's also part of a triangle that we know 2 of the sides to. Just like the one in green, we have a right triangle. Well, that's 90 degrees, so that means, according to the corollaries at the top, the other 2 have to add up to 90 degrees. So I could shortcut this and say the measure of angle 2 plus 38 degrees is equal to 90 degrees. And subtract 38, so we get 52 degrees. Okay, now it's not too difficult. I see that I have a right angle here and a right angle here. I could take this right angle, so that's 90 degrees, and I see that angle 3 and angle 2 add up to 90. So I'm going to take the measure of angle 3 plus angle 2, which was 52 degrees, is equal to 90 degrees. And when I subtract 52, I get 38 degrees. Now for angle 4. I'm going to erase some of this so that I can get to angle 4. Here's some things I know. I know that this is a right angle because it's right next to another right angle and it's a linear pair. I know that angle 3 is 38 degrees, so I can use that corollary that, well, I've got a right triangle, so the other 2 angles have to add up to 90. So the measure of angle 4 plus 38 degrees is going to equal 90. So the measure of angle 4 is 52 degrees. So, we just got to put all the puzzle pieces together on that. And then you do have an assignment. We're going to do page 250, numbers 1 through 11 all.